In the previous segment, we talked a little bit about the fact that we are concerned with 1NF relations, but not all 1NF relations are created equally. We're particularly interested on relations that are 3NF or they are BCNF. So if our original design has relations that are not 3NF or BCNF, then we want to decompose them into relations that they are of either one of these types. So before we can do that, then we need to define BCNF and we need to define 3NF. So in this segment, we are going to concentrate on BCNF. Remember, voice code, normal form. Normal form. The definition is in the text, in the notes, so I don't see any point on rewriting it here. And so let's assume that we have a relation, and let me use an example instead. So let's assume that we have the relation A. Let me use a different color for this. Let's assume that we have R A, comma B, comma C, comma D, and they have the following functional dependencies. We have A, B implies C, C implies B, and C implies D. Let me actually throw just one extra just to make a point obvious. So I'm given this relation. So the question is it BCNF? Okay. So what we do is the following. We go through every single one of the functional dependencies and ask the question. Either is the FD trivial, or is the left hand side a superkey? A BCNF relation is such that for all the functional dependencies of a relation, it satisfies one or the other. So this also gives us an algorithm to determine whether a relation is BCNF or not. We test every single one of the functional dependencies. If one of them doesn't satisfy the condition, then that means that the relation is BCNF. Let me repeat that. If every one of them satisfies either one of the conditions, then it's BCNF. I think I said it backwards. Or if one of them does not satisfy either condition, if one of them does not satisfy it, it's not BCNF. Okay? Let's do the example. So let's look at the first functional dependency. Is it trivial? Yes, because A is a subset of the left-hand side. So this is trivial. So this passes. This is okay. What about AB implies C? So how do we know if the left-hand side is a superkey? What we do is we compute the closure using all the functional dependencies. So we start and we say, well, if we start with AB, and then once we have B, we add C via this functional dependency. Once we have C, we add D. Voila, we have all of the attributes. That means that AB is a superkey. So great. So that also said, because AB is superkey. Let's go to the next one. Is C a superkey? Well, C gives me B, and then C also gives me D, and that's all. I cannot add A. So C is not a superkey. And both of these have C. So C is not, let me use a different color to highlight this. C is not a superkey. So this, both of them do not satisfy the conditions. So the moment that we find one, in this case we found two, that means that R is not BCNF. Okay? So let me state it again. A relation is BCNF if and only if for any one of its functional dependencies, the functional dependency is trivial. So the right-hand side is in the left-hand side, or the left-hand side is a superkey. Okay. Notice that F doesn't have to be a minimal basis. F doesn't have to be in canonical form. It doesn't matter what F we're given. We don't have to do anything to F. We just have to go through every single one of the functional dependencies. The moment that a functional dependency does not satisfy either one of these rules, the relation is not BCNF. Let's leave it at this, and we'll continue in the next one.